Welcome, ladies and gentlemen, to lesson 6.3. I can find the sum of the angle measures of a polygon and the measure of an interior angle of a regular polygon. A lot of vocabulary again in this lesson, noticing some familiar words: sum, angle measure, polygon, regular polygon. One bad piece of news: I can't find my good stylus, so I have a different one. Hopefully this goes smoothly for us. So this is something that you're going to want to pause and write in, either right now or as we go. Definitely a chart, maybe pause now and then fill it in, and then play it when we fill in all the rest of the blanks, and then add to those as you go. So this is just really looking at a polygon, okay, which we need to know the definition of as well. Different shapes, 3 or more sides, closed figure. So what their names are and the number of sides. So a 3-sided is a triangle. We know what that looks like. The number of triangles that fit inside is just 1. The sum of the angle measures, meaning this angle, and this angle, all add up to 180 degrees. Whereas we have a quadrilateral, 4 sides. There are 2 triangles in there. You can cut it like that. That means there's 360 degrees. A pentagon, there's 3 triangles in there for 540 degrees. A 6-sided is a hexagon. These are going to be really small, but if you go from every outside angle, it's getting messy now. Do that with your pencil. There are 4 triangles for 720 degrees. A heptagon is 7-sided. This is actually way better. If I had my other stylus. 7-sided, make sure that looks pretty. With 5 and 900 degrees. An octagon has 8 sides. Draw a stop sign right there if you want to. That's 6 and then 1080 degrees. A nonagon is 9-sided. Just 7 for 1260 degrees. This is a chart you're going to use on tests and quizzes. A decagon is 10-sided, and that has 8 triangles inside of it for 1440 degrees. So an n-gon, meaning we could find any shape. So I could say, what's a 20-gon? How many sides does that have? And the number of triangles inside, you'll notice, is always 2 less than the number of sides that actually make up the shape. So we'd say the number of sides minus 2. What that means is a triangle is 180, so however many triangles there are, you multiply it by 180 degrees. So our formula is n minus 2, number of sides minus 2, how many triangles there are, times 180 degrees for every triangle inside of that shape. So this is the discovery, and this is something very important. Interior angle sum of a polygon. So the sum of the measures of the interior angles of a polygon is n minus 2 times 180, okay, where n represents the number of sides. This gives us the interior angles of a polygon. So let's do some work to find out some measures. Looking at example 1, we are going to find the sum of the measures of the interior angles of a decagon. So this is where we have to know a decagon is 10-sided. So our formula is the sum is the number of sides minus 2 times 180. We are going to fill in that a decagon is 10 sides in for n. So we get S equals 10-sided figure minus 2 times 180. So find out that the sides, there's going to be 8 triangles at 180 degrees apiece. So we find 8 times 180, and we find out that a decagon has a sum of 1440 degrees. Try these, and I know you can see a little bit of it, which is great. Hexagon. Biggest thing we need to do is know what shapes these are. Hexa is a 6, and I think these notes say 7. Let me go back and check. Hexa, yes, 6. If it was a heptagon, it'd be 7. So those notes are a little off. So the side, we need to write down our formula first to make sure we plug everything in correctly. So our sum is our 6-sided minus 2 to find the number of triangles. So our sum is 4 times 180. So the sum of our angles is 720 degrees for a hexagon. Octagon is 8. Write our formula first. Plug in our number of sides. And subtract. Order of operations says I have to do inside parentheses first. Now I find out that the sum of the interior measures of a octagon are 1080 degrees. 15gon, that's what they're called after 10, is just the number and then the gon. Writing my formula. Plugging in the number of sides, which is 15. Finding out that there are 13 triangles within a 15gon, which gives us 1,380 measures. Don't know why I keep writing S's as 8s. Which gives us 2,340 degrees in a 15gon. It's all about writing an equation, knowing the number of sides, plugging in, and order of operations. So now we need to know something about equilateral. A polygon is equilateral. Equal. All incongruent are the same. All sides are congruent. And equiangular, all angles are the same. If that's true, it's a regular polygon. Just regular. Everything's the same. So, if all the angles of a regular polygon are congruent, the measures are all equal. So, these are examples of regular polygons. Notice these lines indicate the sides are the same. That symbol indicates that the angle measures are the same. Copy that down in your notes. The Ennis Brown House in Los Angeles, California, shown at the right, was designed by architect Frank Lloyd Wright. The exterior of the house consists of repeating regular quadrilaterals. Noticing all those squares, quadrilaterals, 4 sides. We are going to find the measure of an interior angle of a regular quadrilateral. So, how to do that? Well, first we have to find out how many total sides there are. So, we have to decide, okay, a quadrilateral means it has 4 sides. So let's find the sum. So we say the sum is the 4 sides minus 2 times 180. I'm going to run out of room. So we find out the sum is that there's 2 triangles times 180. So a quadrilateral has a sum of angles of 360 degrees. But the question says find the angle measure of one interior angle on a regular quadrilateral. So what we do now is we divide the sum by the number of angles. So we're going to take 360 divided by 4, and we find out that one angle is 90 degrees. Since they're all the same, each of them is 90. 90 plus 90 plus 90 plus 90 is 360. So one of the angles on that 4-angled shape is 90 degrees. So let's do this. Now again, just reading directions is the only tough part, I think, in this. We're finding the measure of one interior angles, not the sum, just the one, but we need the sum to find it. So remember, we're going to find the sum and then divide by the number of sides. We're also going to read directions because it says round to the nearest 10th. 10th place is right here, so sometimes we have to look to the 100th place to determine if we need to round up or stay the same. Octagon, 8 sides. So here's our formula. And I actually write a new formula, so it's the sum, then I eventually divide. So If you want to put in your notes this, not the sum, but one interior angle, one of a regular, I'm going to call it, polygon. The formula for that is really the formula for the sum, and then all of that divided by n. Okay? So I plug in, back to my octagon here, 8 minus 2 times 180, and I get S equals 6 times 180. So the sum is 1080, but that is divided by the number of sides, which are 8, number of angles, which is 8 in an octagon. So I find out that one interior angle is 135 degrees. Next one, heptagon. Now this is a 7. So the sum, use your formula, plug in the side length, 5 triangles in a heptagon for a total sum of 900 degrees. But to find the angle measure, we're going to divide that by the number of angles, 7. And that means that one interior angle is, we're going to do 900 divided by 7. I don't think that goes in evenly on your calculator. You end up getting something like 128.57. So that 7 is going to round that 5. Oh my goodness. No stylist. To a 6 degrees. Bear with me. All right, let's do this 20gon. Let's try to be neat here. 20gon, 20 sides. Formula. Plug in for the 20. That means there's 18 triangles at 180 degrees each, which means my sum is 3,240 degrees. And that is split evenly among the 20 angles. So that means that one interior angle is equal to, so we do 3,240 divided by 20 for a value of 162 degrees each. All right, kind of rambling there, but just knowing Polygon, knowing our language, rewatching what you need to, remembering our formula and which ones they go for. So this is looking for the sum, and finding the sum and dividing by the number of angles is finding one interior angle. Good luck. See you soon.